Welcome to our channel. Today we're diving into the fascinating world of transient astronomical events that you've probably never heard of. Now, you might be thinking, transient what? Well, get ready to have your mind blown, because these events are like the universe throwing a surprise party, and we're all invited. These are rare, short-lived phenomena that can teach us a lot about the universe. Imagine, for a brief moment, we get a glimpse into some of the most energetic and powerful events in the cosmos. It's like catching a shooting star, but on a much grander scale. So, buckle up, space cadets, as we explore the mind-blowing world of transient astronomical events. So, what exactly are transient astronomical events? Well, the universe is a vast and ever-changing place. It's not just stars sitting there twinkling politely. No, the cosmos is a dynamic and lively place with things constantly happening. And some of these events, my friends, are like cosmic flash mobs. They pop up out of nowhere, put on a spectacular show, and then vanish just as quickly, leaving us to wonder, what just happened? We're talking about things like supernovas, gamma-ray bursts, and fast radio bursts, just to name a few. These events are fleeting, lasting for mere seconds, minutes, or maybe days, which, on a cosmic timescale, is like the blink of an eye. But don't let their short duration fool you. These events are some of the most powerful and energetic in the universe. Think about it. Our sun is a pretty impressive star, right? It provides light and warmth, sustains life on Earth, and keeps our solar system in check. But even our sun pales in comparison to the sheer energy released by a single supernova or a gamma-ray burst. These events are like the universe turning up the volume to 11 and then some. Now you might be wondering, why should we care about these fleeting cosmic phenomena? Well, for starters, they're incredibly cool. I mean, who doesn't love a good cosmic mystery? But more importantly, studying these transient events can teach us a lot about the universe we live in. Think of it like this. Imagine you're an alien archaeologist visiting Earth a million years from now. How would you piece together the history of our planet and its inhabitants? You might study fossils, ancient ruins, or even the geological record. These are all remnants of events that happened in the past, and they can tell us a lot about the history of Earth. Transient astronomical events are like fossils of the cosmos. They provide us with clues about the life cycle of stars, the nature of gravity, and even the origins of the universe itself. By studying these events, we can learn about the processes that shape the universe we see around us. Now let's talk about one of the most mysterious and intriguing transient events, fast radio bursts, or FRBs for short. These are incredibly short but incredibly powerful bursts of radio waves that originate from billions of light years away. We're talking about a signal that lasts for a few milliseconds at most, but in that time, it releases as much energy as our sun does in an entire day. The first FRB was discovered back in 2007, and since then, we've detected hundreds more. But here's the catch, we still don't know for sure what causes them. It's like hearing a knock on the door, but having no idea who's on the other side. It's both exciting and a little bit unnerving. There are many theories about what could be causing FRBs. Some scientists believe they could be caused by highly magnetized neutron stars, the collapsed cores of massive stars. Others think they might be the result of collisions between black holes or neutron stars. And then there are those who speculate that FRBs could be signals from advanced alien civilizations. Now, I know what you're thinking. Aliens? Really? Well, I'm not saying it's aliens, but it's definitely not off the table. After all, FRBs are unlike anything we've ever seen before, and they seem to originate from galaxies billions of light years away. So, it's not entirely out of the realm of possibility that they could be artificial in origin. But even if FRBs turn out to be caused by some exotic astrophysical phenomenon, they're still incredibly important to study. These bursts carry information about the intergalactic medium, the vast spaces between galaxies. By analyzing the way FRB signals are distorted as they travel through this medium, we can learn about its density, temperature, and magnetic fields. So the next time you hear about a fast radio burst, remember this. It's not just a blip on a screen, it's a cosmic enigma, a message from the distant universe waiting to be deciphered. And who knows, maybe, just maybe, it's a sign that we're not alone in the cosmos. Let's move on to another fascinating and slightly terrifying transient event, tidal disruption events, or TDEs. These events occur when a star gets a little too close to a black hole, and let's just say things get messy. Imagine a black hole as a cosmic vacuum cleaner relentlessly sucking in anything that gets too close. Now imagine a star, minding its own business, orbiting peacefully in a galaxy. But then, disaster strikes. This star wanders too close to the black hole, and the black hole's immense gravity takes hold. The star, caught in the black hole's gravitational grip, begins to stretch and elongate like dough being pulled apart. This process, known as spaghettification, is not pretty. The star gets stretched thinner and thinner, forming a long, thin stream of gas that spirals around the black hole. As the star's material falls onto the black hole, it heats up to millions of degrees, releasing a tremendous amount of energy across the electromagnetic spectrum. This outburst of radiation is what we observe as a tidal disruption event. It's like the black hole is having a cosmic snack, and we get to witness the aftermath. TDEs are relatively rare events, but they provide us with a unique opportunity to study black holes up close and personal. By observing the light emitted during a TDE, we can learn about the black hole's mass, spin, and even its feeding habits. Think of it like this. Imagine you're studying a lion in the wild. You could observe its behavior from a distance, but you'd learn a lot more if you could see it up close, feeding on its prey. TDEs are like getting a front row seat to a black hole's feeding frenzy, and they allow us to study these enigmatic objects in unprecedented detail. Now hold on to your hats, folks, because we're about to delve into the world of gamma-ray bursts, or GRBs. These are the most powerful explosions in the universe, and they make supernovas look like mere sparklers. Imagine for a moment that all the stars in our galaxy decided to explode simultaneously. That's a lot of energy, right? Now imagine an explosion that releases more energy in a few seconds than all the stars in the observable universe combined. That, my friends, is a gamma-ray burst. GRBs are brief, intense flashes of gamma rays, the highest energy form of light. They were first detected in the 1960s by satellites designed to detect nuclear explosions on Earth. But these bursts weren't coming from Earth, they were coming from deep space. So, what could possibly cause such a mind-bogglingly powerful explosion? Well, there are two main types of GRBs: long-duration bursts, which last for a few seconds to a few minutes, and short-duration bursts, which last for a fraction of a second. Long-duration GRBs are thought to be caused by the collapse of massive stars at least 10 times the mass of our Sun, as they die and form black holes. These events are sometimes referred to as hypernovae because they are even more powerful than supernovas. Short-duration GRBs, on the other hand, are thought to be caused by the collision of two neutron stars, or a neutron star and a black hole. These events are like cosmic fender benders, but instead of crumpled metal, they produce some of the most energetic explosions in the universe. GRBs are not only incredibly powerful, but they're also incredibly bright. In fact, for a brief moment, a single GRB can outshine the entire universe. That's like a firefly momentarily outshining the sun. And finally, let's talk about one of the most well-known and spectacular transient events, supernovae. These are the explosive deaths of stars, and they're responsible for creating many of the elements that make up our universe, including the iron in your blood and the calcium in your bones. Stars are like cosmic pressure cookers. They spend most of their lives fusing hydrogen into helium in their cores, releasing energy in the process. This outward pressure from nuclear fusion balances the inward pull of gravity, keeping the star stable. But eventually, even stars run out of fuel. When a star about 8 times the mass of our Sun or larger exhausts its hydrogen fuel, its core collapses, triggering a runaway nuclear reaction that rips the star apart in a massive explosion. This is a core collapse supernova. Another type of supernova, called a type Ia supernova, occurs in binary star systems, where two stars orbit each other. If one of these stars is a white dwarf, the dense remnant of a Sun-like star, it can steal material from its companion star. This stolen material can cause the white dwarf to reach a critical mass, triggering a thermonuclear explosion that obliterates the white dwarf. Supernovae are incredibly luminous events, shining as brightly as billions of suns. In fact, for a brief time, a supernova can outshine the entire galaxy it resides in. It's like a single light bulb illuminating a city. But supernovae are more than just dazzling light shows. They're also the universe's way of recycling material. The explosions scatter heavy elements, forged in the star's cores throughout space, seeding the interstellar medium with the ingredients for new stars, planets, and even life. So the next time you look up at the night sky and see a twinkling star, remember that some of those stars will one day meet their end in a spectacular supernova, enriching the universe with the building blocks of life. Thanks for watching. If you enjoyed this video, make sure to like, subscribe, and hit the bell icon for more fascinating science content. Space is full of surprises, and by studying these transient events, we're getting closer to understanding the inner workings of our vast and mysterious universe. Let us know in the comments which transient astronomical event you found the most interesting. Was it the enigmatic fast radio bursts, the terrifying tidal disruption events, the mind-boggling gamma-ray bursts, or the dazzling supernovae? Until next time, keep exploring the cosmos and never stop asking questions about the universe around us.